addition, we've identified ways to reduce the hydrogen that we have to flare during startup, and we're working on both project design and permitting. We're going to continue to communicate openly and operate in a safe, reliable, and environmentally responsible manner. And we're committed to providing $140,000 per year for 5 years, starting this year, in support of the Torrance City program. So, thank you.
Okay. I'll speak without the slide. I think most folks know that about a year ago in this room, the AQND committed to completing a study regarding alkylation technologies in the refining industry. They completed that study. I know they provided the results and a copy of that report by Norton Engineering to the city. That report is extremely consistent with the information we have been sharing with the community for the past several months. It concluded that the only currently viable technologies for alkylation are sulfuric acid or hydrofluoric acid. There is a third emerging technology, a liquid ionic technology. Chevron has announced that it is going to build a facility in Salt Lake City. It's around a little bit more than a tenth of the size of the unit in Torrance. It should be online by around 2020. We are very anxious to see how that technology works in Salt Lake City. If it performs as advertised, we think it has a great deal of promise. Until then, we have two viable technologies. Our only difference with the Norton Engineering report is on its conclusion regarding a potential switch from modified hydrofluoric acid to sulfuric acid. No refinery in the country has ever made such a switch. Their estimates of time and cost for that project are grossly overstated. I make that statement based on two facts. One, their report admits that they make certain assumptions about what equipment might be able to be reused within the existing unit, and that the footprint would place the new unit essentially right next to the existing one. Neither of those really hold true. The two technologies involve the use of very different equipment, different metallurgies, and you cannot put a new unit right in place next to the existing unit. So we would be building a whole new grassroots sulfuric acid plant somewhere else on the facility and having to build infrastructure to connect it to the refinery. Second point is Valero has announced, I think it was late last year, early this year, they are building a new sulfuric acid plant that is about half the size of what we would need in Torrance. They're building it at one of their refineries in the Gulf Coast. That project has an advertised price of $300 million. So in order to build that project in California at approximately twice the size, I think we can all pretty much do the math. It will also obviously be a new emission source and involve permitting that would be involved in building any new manufacturing or petrochemical type complex in Southern California. So while I'm not saying it's infeasible, the Norton report, we feel, and we've conveyed this to AQND, personally understates that one area in the report. But otherwise, we were supportive and felt like the report reached conclusions that we've already been sharing.
Move on then to Southern California Medicine.
Honorable Mayor, distinguished council members, city staff, residents of Torrance, good evening. My name is Paul Lugo. I'm the Vice President for our Transmission, Substations, and Operations group in the company. And let me first thank you for giving us the opportunity to provide some context and details as to the outages that occurred in September and, or the disturbances that occurred in September and October. And then we also apologize on behalf of Southern California Edison to all of you, the first responders, the residents of Torrance, as well as our customers, for the impact that these outages have caused to all of you. So, not something that that represents the reliability that we strive to provide our customers, and we are committed to working tirelessly and continuously working at improving that service that we provide our customers, including the refinery. If we could move to the next slide. So, I'd like to spend the next several minutes providing a bit of background on maybe a couple terms that we'll be using here over the course of the next several minutes, and how those types of disturbances impact both a refinery operation versus residential and commercial customers. So I'll spend a few seconds on that. Then we'll talk about the cause of the outages both in September as well as October. Thoughts that we have on how to avoid similar events in the future, and steps that we've taken in the past to in fact mitigate these types of incidences, and then a quick review of how we manage maintenance related outages as well as repair related outages. So just to clarify, the events that occurred in both September and November were events that were related to a substation, as Jack pointed out, or I believe it was Steve described. We serve the refinery and about 160,000 of our customers from the Refinery substation. So these events occurred out of Refinery, or lines that were associated with Refinery, as opposed to lower voltage, what we call distribution systems that provide service out within the community. So it's really at the source, if you will, that we experience these challenges. Move on to the next slide. So there's a difference between a voltage dip and an actual outage. So a voltage dip is typically caused by these examples that are provided here: mylar balloons, car heat poles, critters that actually impact our infrastructure, fog, as we know, and I'll describe that in a moment. A variety of different types of causes that momentarily, and when I say momentarily, typically within a fraction of a second, can impact service to our customers. Most customers may not even notice that we have these types of voltage dips. You may see a bit of a flickering light, that typically doesn't impact other types of services. An industrial customer such as a refinery that has very complex, sophisticated machinery and equipment can be susceptible to being vulnerable to these types of dips. So in both cases, the refineries could be impacted. A power outage is an instance where we literally lose service for several seconds to a minute to maybe even longer than that, where there is a disconnect, if you will, in the service that we provide our customers. Oftentimes, those represent equipment failures. So in the instance of a car heat pole, which unfortunately happens more often than we'd like to believe, you could have an instance where a wood pole would be cut in half. Conductors coming down the ground are severed, and we effectively now have an energized line, and our protected devices or schemes in our substations interrupts power within a matter of a split second to ensure the continued safety of the public. That would literally interrupt power for several minutes until there's a repair that's underway, or we're able to serve power through a different path to our customers for several minutes. So that is an outage. So that's the background I wanted to make sure I provided. Let's move on to the next slide, and I'll talk about the September event. So in September, there were two days where we had some disruptions. On September 18th, we had a voltage dip, and that event lasted 0.1 seconds, and it occurred on lines that were not feeding the refinery. It occurred on lines that were feeding other residential customers throughout the Torrance community and other communities. And because those lines are being served by the same system that serves the refinery, there is oftentimes with these dips, depending on how significant the fault is, there is an upstream effect, if you will, to the lines serving the refinery, because they share what we call the same bus, the same system. And that is not uncommon, unfortunately, for customers being served off of different lines that are sharing the same system as those lines that were impacted by a fault, whether it's a fog, car hit pole, raccoon in the lines, or mylar balloon, to see some form of voltage dip. As I stated earlier, oftentimes if the voltage dip is severe enough or of a longer enough magnitude, it could impact operations at a refinery. I think as Jeff indicated earlier, most refineries, in fact, that we serve in Southern California actually do have a dedicated service. They've chosen to install a dedicated service, and we've done that. So this is somewhat of a unique configuration that we've had here with ExxonMobil and now PBF Energy that has inherited or acquired these assets. So in the instance of September 18th, 19th, there was a very unusual fog, typically we don't see during this period of the year, that occurred. Fog and the humidity in the air can effectively allow particulates that do accumulate on our insulators. There are components of our towers and poles to create a path across the insulator and create an arc which is picked up by our protective schemes as a fault on the line. And to protect the public and ensure that we don't damage equipment both within the substation and outside, on the customer end, we interrupt the lines, if you will. And so that's what occurred. There was a 10th of a second interruption on the 18th. As a result of that interruption, which occurred around 6 o'clock in the morning on Sunday, the 18th, we did have our linemen, patrolmen we call them, that regularly patrol our lines to visually inspect the lines and identify what may have been the cause of these lines. This is sort of a typical practice that we go through whenever we have an interruption on any lines, in fact, but especially on a transmission line or sub-transmission line, which this is. And it was identified in that inspection that, in fact, there was probably a fog-related events that created an arc. There was some hot washing that was conducted later that day. So hot washing is literally hosing down, if you will, with a very high-powered gun, water gun, insulators and conductors to remove these particulates that could be the cause of these arcs. So that was conducted later in the day. We identified some additional washing that needed to occur. The following day, on the 19th, unfortunately, we experienced a similar fog. And at 3:30 or so in the morning on Monday the 19th, we experienced more faults on more lines, and which did result in a number of voltage dips. At some point in time, our protective scheme is such that we need to take a relay or protective device out of service in fear that it may not be operating properly. It's a standard protocol that we take, and in this case, that is what occurred, which resulted in us interrupting power to a number of our customers in Torrance and other neighboring communities for several minutes before we were able to patrol those lines. In all of these cases, the refinery experienced dips in voltage that lasted anywhere from 0.1 seconds to 1.4 seconds, and 1.4 seconds is a long time. So that's what occurred on the 18th and 19th. We can move on to the next slide. So the October 11th outage is not related in any way, if you will, to the September outage. And a little bit of context here, I believe, would help. We've been engaged at SCE, Southern California Edison, in a multi-year project, specifically at La Fraser substation and all of its downstream substations that it feeds. It feeds about 20 substations downstream on a multi-million-dollar, multi-year upgrade of the station, including adding